We better go on 3 and 5. We got to do a good job on this section. Suppose a single fair die is rolled. Find the probability that an odd number given. See, we're starting out with the given, right? This is conditional probability. This is the last section that's on our exam a week from today, next Thursday. Given it is a 5. So understand what that's saying. That's saying, hey, I got a die. I rolled the die, covered it up, didn't let you see it. I rolled it, and I said, okay, I want you to tell me what's the probability it's an odd number. If I just said that, and I didn't say anything about the given 5 thing, what if I just said, what's the probability it's an odd number? What would you say? Well, if I just said that, forget about this part for a minute. What if I just said, hey, I just rolled a die, just a 6-sided die, 1, 2, 3, 4, 5, 6. I just rolled it. How many odd numbers are there? 1, 3, and 5, 3 of them, huh? Those are the odd numbers, right? So if I just said, what's the chance, I just rolled a die, what's the probability I got an odd number?
1 over 2.
Right, because it's 3 out of 6, which reduces to be a half, huh? Good? Because there's a total of 6 different things that can happen, 1, 2, 3, 4, 5, 6, and 3 of them are odd numbers, right? Okay, but that's different than what they're asking. They're saying this weird thing at the end. Given it is a 5. So what's the probability that you got an odd number? Given, that's what that straight line means. It's shorthand notation for the word given. It's saying you're given. This it was a 5. So I rolled the die. I said, hey, what's the chance I got an odd number? By the way, it's a 5.
100.
Yeah. If it's a 5, there's no mystery, is there? It's an odd number. It's 1 out of 1. It's 1. It's 100%. Right? If I got a 5, I got an odd number. The mystery's over. If they're going to tell me exactly what they got, well then, okay, thanks. 100% chance you got an odd number because you got a 5. Tracking with me? Does that make sense? So the given is what you know, what they're telling you. And the first part is what you're wondering about. Good? Let's try another one. Okay, roll a die. Probability it's a 2, given it's even. So you got to be really clear on what you're wondering and what you're knowing. So what you're given is what you're told. Right? They give you that. They speak that. They give you that information. So they roll the die, cover it up, and they say, hey, I got an even number. I'm giving you that much information. I got an even number. So if they got an even number, what might they have gotten? 2, 4, or 6. They had to get either 2, 4, or 6. If they got an even number, they got either 2, 4, or 6. So what's the probability that it was a 2, given it was even? 1 out of 3. Because 2 is one of the 3 possible things, huh? Is that making sense now? So the given tells you the denominator, doesn't it? The last problem, they gave us it was a 5, so there's only one thing in the denominator. So 2 dice are rolled. What is the probability that the sum of the points total 8 if the first die is a 4? So let me let you think about that. So write out what's possible there for me. Write out, that's what will really help you. Write out everything that's possible. What are they giving you? What's the given? What's the we know this for sure? Do we know the total's 8? No, they're saying what's the chance the total's 8? That may not be. What's the chance of rain today? What's the chance the total's 8? We don't know. We don't know that for sure. What we do know is the first die is a 4, right? You understand? You good with the sentence there? See what that sentence is saying? They say math is one of the best things if you want to become a lawyer to do as your undergraduate. Isn't that a weird thing? Why in the world, if you want to become a lawyer, you can do any undergraduate you want. You just do any degree you want and then take the LSAT and go to law school. My nephew's doing it right now. Math is actually a really good thing to do as your undergraduate. Why? Math will force you to read very well. That sounds weird to say, huh? Math, reading? But yeah, and you go higher math, it's almost all words. It's a lot of words. And it makes you a precise reader, which is what lawyers need to do. They need to read and write contracts Very precisely. So make sure, so do you see what that's saying? Practice your reading comprehension. See what that's saying? What's the probability that the sum is 8? That's what we don't know. That's what we're wondering. If, when I say if something's done, right? I say, what's the chance, yeah, well, I don't have a good example. Let me just leave that. If the first die is a 4. So the first die is a 4. The first die is a 4. They got a 4 and a something, didn't they? 4 and a something. So what are the possibilities? They could have got a 4 and a 1, a 4 and a 2, a 4 and a 3, a 4 and a 4, 4 and a 5, or 4 and a 6. Wouldn't you agree? One of those 6 things happened. For sure. Right? Because the first die is a 4. They're telling me. This is what's given. The first die, this first die was a 4. The second die, I don't know. So it's 1 through 6. So anyway, I got a 4-1 or a 4-2 or 4-3, 4-4, 4-5, 4-6. So the probability, what's the denominator? 6. Remember that the given always tells you how many things are possible, right? Bottom of probability is total. So there's 6 different things. There's 6 different, you either got a 4-1, or you got a 4-2, or a 4-3, or a 4-4, or 4-5, 4-6. Okay, what's the chance your 2 dice total sum to be 8? Yeah, only if you got a 4-4 do they total 8, huh? 1 out of 6. How we doing? It's making sense? So it's condition. They're given a condition. The condition is the first die was a 4. Good? All right. It's good. I'm probably going too slow. I need to get to those hard ones. Okay, try it out. What's the probability that the sum is even if the first die is even? So give that a try. The sum is even if the first die is even. Okay, what do y'all think? Any answers? Half it is. Half it is. Right? The first die is even. So that means they either got a 2 on the first die, or a 4 on the first die, or a 6 on the first die. The first die was even. What's the second die? I have no idea. So it could have been 2-1, 2-2, 2-3, 2-4, 2-5, or 2-6. Or it could have been 4-1, 4-2, 4-3, 4-4, 4-5, 4-6. Or it could have been 6-1, 6-2, 6-3, 6-4, 6-5, 6-6. It's one of those, what is that, 18 possibilities, isn't it? You with me? Because the first die was even. So the first die was either 2, a 4, or 6. The second die, I don't know. It could be anything 1 through 6, huh? 18 possibilities. Among those, how many have a sum even? Well, this is even, 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 this is even. They add up to even numbers, don't they? 9 out of 18 and a half. Or you could just say, look, if the first number is even, the second number could be even or odd, half and half. Even's the only way it can be, half, right? You don't have to be all, write everything out like that. All right. Good. Stop me. Want to talk about it? I'm probably not going to test you heavily on this. This is about independence or dependence. Basically, determine whether the events are independent or dependent. Justify your answer. I'll give an easy way to do that. Basically, independent things, one does not affect the other. One does not affect the other. So what would that mean? That'd be like me saying, hey, what's the probability that I'm going to do well on the exam next Thursday if it rains? Now, whether it rains or not has nothing to do with whether you're going to do well or not do well on the exam. It has to do with studying, right? So those are two things that are independent. Versus you could say, what's the probability I'm going to do well in the exam next Thursday, given that I get off work Monday through Wednesday so I can study or whatever. Now that might be connected, you know, it gives you more time to study. So you see that, so some things are dependent, some things affect one another, like not having to work so you can study. Or my daughter talking about that, she had to work at the end of last quarter and her grades went down, versus rain or no rain. That doesn't affect whether you're going to do well, right? So some things are independent, some are dependent. So independent means they're separate. They don't affect each other. All right, so here we go. So what's the question? So the two things, a person attaining a position as a professor and them having a PhD. Is having a PhD have anything to do with becoming a professor? Well, yeah, like at Fresno State, you can't become a professor unless you have a PhD or some kind of doctorate, right? Yeah, those are related, right? So are they independent? No, they're dependent. It's either A or B. I don't know what the rest of those words are. So either A or B, they're dependent. Because attaining a position as professor has no effect. No. Must be B. Dependent because attaining a PhD can affect the probability of that same person becoming a professor. Yeah, absolutely. So B. They're dependent. Is that making sense? Good. So then they ask you a bunch of other questions like that. I'm going to move on. That's okay. Help you understand them. So A and B, let A and B be independent, blah, 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 blah. Basically, here's a special rule you can put on your 3x5 card. If A and B, when A and B are independent, then, when that's true, then the probability of A overlap B is the probability of A times the probability of B. So I want to explain that a little bit to you so it makes sense. Yeah, okay, let me give you an example. What if A is getting the number 2 on a die? We're rolling a die here. What if B is getting an even number? Are those independent or dependent? Yeah, are they related to each other? Yeah, they're related, right? If you got an even number, you might have got a 2. If you didn't get an even number, no way you got a 2. They're intertwined, right? They're not totally separate. Whereas if I said you flip a coin, whether you get heads or not, and then whether you got a 2 on a die, they're nothing to do with one another. That'd be independent, right? So let me change. Let me make an independent one. So there we go. So I'm flipping part B. I'm flipping a coin. Got heads or tails. Part A. I'm rolling a die. Got a 2. Independent. Have nothing to do with one another, right? Getting the heads doesn't make any more likely to get a 2 or not. Those are independent. So what does that mean then? Hey, I'm playing this game, this weird game where you flip a coin, roll a die, and I really want to get a 2 on the die and then a heads on the coin. What's the probability that I'll do A overlap B? What is over? You turned over, right? I hope if you did 8.4, you learned some more, got more comfortable about what overlap means. What does overlap mean? And. Both and. How you doing on that? Both and. That's a lot of the trick of this chapter is getting really comfortable with that you and the overlap. We're getting really clear on what those mean. So that's both and. That takes time. If you just start looking at that an hour before, 2 hours the night before the exam, it's going to be a bad day next Thursday. I'm telling you the truth because I want good for you. This takes time to digest. Math and science is not like history. Abraham Lincoln's the 16th president. Got it. Done. Right? But this and or how it logically connects, complex. I'm not putting down history. I love history. If I do it again, I'd do history. But I'm just saying the nature of math, it's just science, it takes time. So I'd look at this every day. Look at that practice exam, work through those, look back at the homework, work those, think about those, go see tutors if you want to do good on this exam. That's what it takes in math and science. That's why math and science is the big cutter. It cuts people out. I don't want you to be cut out. So study hard so you can do that. So, and or, this means both and. So when I write this, it means both A happens and B happens. Both you get a 2 and you get a heads. What's the probability that both are going to happen? That I'm going to get the 2 and get the heads? Well, it's whatever the chance of A is. What's the chance I'm going to get a 2? You roll a die, what's the chance you're going to get a 2? Just that, nothing more. Just 1/6, right? There's 6 things that can happen. 1/6 chance of getting a 2. What's the chance of just be all by itself getting a heads when you flip a coin? 1/2. There's just heads and tails, so heads and half. Multiply that together, 1/12. That's the chance that you're going to do both. The chance you're going to both get a heads or get a 2 and get a heads. One out of 12 times you try that little double flip and roll the coin thing, you'll make it happen. Okay, now, what if I changed it? What if I go with C and D? That's what this formula is saying. If you want the chance that both and are going to happen, both and, that's what the overlap means. But remember, you can memorize this. It's like an A. How about that? And. Does that help? It's like an and. That's not, yeah, that's partly helpful. There's a reason I sort of hold off on that at times, because the other one can seem like and. Anyway, we'll talk about it more as we go today. Probably A, it really does take time. This is a slippery concept. You need to work a lot of problems. And then that's how you learn. It's just problem after problem after problem. Nothing will teach you, nothing like reading definitions. That doesn't, just throw the book away. Do problems. That's how you learn math. You do problems. There's nothing else like doing problems and getting help with those problems when you're stuck. So do lots of problems with and or, and then you with the overlap and you, and then it'll start making sense. Anyway, let me change to C and D now. So I just used this formula. Probability of both and is the first one times the second one. Why would that not be the case? That's only because they're independent, right? A and B are independent. Flipping, rolling the die, flipping the coin, totally separate, independent. But what if I said, okay, C is getting a 2, just like A was, but D is getting an even. So now we're connected. Those are dependent, aren't? C and D are now dependent, aren't they? They relate. Getting a 2 and getting an even number, that's sort of very similar. They have to do with each other. So what? Okay, well that means that if you say, hey, I'm playing this game, I'm rolling the die, I really want to get a 2 and get an even number. I said, I win this game if I roll this die and I go, yeah, I got a 2. Hey, did you also get an even number? Well, yeah, I got a 2. So yeah, I got an even number, right? So I got a 2, got an even number, I win. So what's the probability of both and? Well, I'm telling you it's not going to equal the first one times the second one. Because that's only true when they're independent. And these are dependent. Let's see it. Let's see it's not going to work. Why? What would be the chance of getting a 2? Just A by itself. Just the probability of A all by itself. What's the chance of just getting a 2 all by itself? 1/6, right? Just chance of getting a 2 when you roll a die. 1/6. Okay. What's the chance of B? What's B? Or in this case, it's D, huh? D. What's the chance of getting an even number when you roll a die? It's a half. It's kind of like the coin flip thing was. Well, it's a 12. It worked out fine, a 12. That ain't true. Think about it for a minute. Both and. What's both and? Got a 2 and got an even. So if I said, hey, I'm doing this game, I'm rolling this die, and I want to get a 2 and get an even. Ready? I'm going to roll it. Did you get it? Did you get a 2 and an even? What? That's a weird way to talk, huh? What does it mean to get a 2 and get an even? What happened? If I rolled the die and say, I did it. I got a 2 and got an even. What does that mean happened?
It's when they overlap that.
Just throw aside all math formulas. Just be real with me. Be real. Probability is real. Real. I rolled a die. Covered it up. Said, hey, guys, I got a 2 and I got an even. What happened on that one die? Just one die. I got a 2. That's just a weird way of saying you got a 2, right? You with me? It's just a weird way of talking. You got a 2 and you got an even. Well, of course if you got a 2, it is even. Why are you saying that? Well, because we're talking weird. But you agree, that means we got a 2. That's what happened, right? So what's the probability of that? What's the probability of getting a 2? Is it a 12? Like we said? No, because we misused the formula. Because you can't use that formula when they're dependent. That's my point. Are you catching me? What's the real chance of getting a 2? It's 1/6. Not 1/12. Why'd that formula tell us 1/12? Because I shouldn't have been using that formula. That formula ain't true for dependent things. That formula is only true for independent. If the things have nothing to do with one another, yeah, then you multiply them. But if they are related to each other, you can't be multiplying them. That's what that formula is saying. Make sense? So you can use this formula right here only for independent events. That's the only time it'll give you the truth. Okay, so then, that's a long explanation to say, probably used up all of our precious time there. What's the probability of A overlap B? It says right here they're independent. So let me go to fresh screen. I've messed that one up pretty good. So when it says if things are independent, then the probability of A overlap B is A times B, right? You can just multiply them. This is what you want to put in your 3x5 card. That formula right there. That when they're independent, If they're independent, then you can do that. So we can do that. They want A overlap B. That's the first thing they want. We'll get to the second thing in a minute. They want that. Well, then I just got to do A, which is they're telling me that's a 9th. And I got to do B. They're telling me that's a 7th. I got to multiply those. 1/63. Bingo. I can do that when they're independent, right? Now, for the $1,000 question. How do I do the second part? How do you do that? Yeah, Venn diagram. We make a Venn diagram. Whenever you got like A, B, and the overlap or something like that, there's the tool. I hope you're getting the hang of. That's what this chapter is about. It's about learning to use the tools. We're like a carpenter. We're learning to use the hammer well, the saw well, the nail gun well to build things, right? That's a lot of what this is. Are you good with Venn diagrams? Are you good with tables? Are you getting better at these? It's not going to come to the casual. It takes practice. You got to get good. You got to look at that and go, oh, I need a Venn diagram. That's what'll hammer this wall together. I need the nail gun. I need the Venn diagram. Why? What makes me think that? Well, I've got A, I got B, and I got the overlap. So that means I've got A, I've got B, and I've got the overlap, and they're asking me for the union. The Venn diagram would be the perfect tool to help me accomplish that. Where do you always start when you use the Venn diagram? Yeah, remember we learned to do the middle? The overlap, what's the overlap? 1/63rd, right in the middle. It's a B here. 1/63rd. Good, that goes in the middle, the overlap. Okay, great. So how do I get like what's out there, for example? Good job. Remember, now this is a weird one because of fractions and everything, but remember, let me make an easier one. What if the numbers, what if there were like 10 total, there was 3 here, this is A, this is B, and I told you A holds 7 altogether, B holds 5 altogether. If A holds 7, there's already 3 in the middle, this would have to be 4, huh? To make 7 total in A. Get the idea? You understand? If you have the middle, right, look at circle A. Circle A is here. It's both these together, isn't it? So over here, circle A is this and this together. We already know part of it is 1/63rd. How do we find the rest of it? Well, they're telling me all of A is a 9th. So I take all of A's got to be 9th, minus the part already used up, 1/63rd. And whatever the difference, that'll be this. Whatever the subtraction is, it'll be that. Do y'all see that? Kind of like over here saying, well, all of A is 7. 7 take away 3. That gives me the 4 is the remainder part. You see the idea? If you know what all of A is, and you subtract the part you already got, the remainder is the rest. Right? So it's weird with fractions, though, isn't it? Fractions are not fun. So let's do that. So to find the rest of this, we got to take all of A, 1/9, minus the part we've already got, that little part of A, 1/63rd. Subtract this. Some of your calculators will do it automatically. That's fine with me. Yeah, you guys have the TIs? Yeah, just type 1 divided by 9 minus 1/63. It'll give you a decimal, and then I'm going to show you a trick. Yeah, it's beautiful. Here, let me show you. You guys got the TIs? Watch this. Well, just go 1 divided by 9 minus 1 divided by 63. Hit enter, you get some crazy decimal, right? And then hit math. Enter. It'll change it to a fraction. So on the calculator, let me write it here. On the calculator, go 1 divided by 9 minus 1 divided by 63. Hit enter, you get this answer. And then you hit the math button on the left and hit enter because it says change to fraction. That's what will come on the screen. You go, yes, please. And it'll hit enter, and you get 2/21. Did you get that? 2/21 out there. Y'all tracking with me? Oops, I didn't turn the Elmo on. Still not on. There it is. Okay. So I'm going to go 1 divided by 9. 1 divided by 9 minus 1 divided by 63. And to get that crazy decimal, come over here and hit math. See the math button? Left side, third row down, math. See the top option says change to fraction, that arrow fraction. It says change to fraction. Hit enter, yes please. It says, oh, take your answer to a fraction. Yes, that's what I want. Enter one more time. 2/21. Good? Getting that okay? I forgot about the light thing. Huh? It just reminded me because we did them all on for that. I forgot about this. Now you can see the lecture. All right. So 2/21. We all good? It's all so much more clear now. Sorry, just remind me. I always forget. All right. Now how do we find what's out here for B? Same kind of thing, huh? We have the B total right here. The whole B circle is 1/7. So the middle is part of the B circle. I want to find the remaining part, subtract. Right? So for the B circle, do the same thing. For the B part there, for the remaining B, take 1/7 minus 1/63. Is it 8/63? Yeah. And that's the remaining part there. Okay, great. So we've done all that. How's that going to help us? They're asking me for the union. The union. Well, here's where we find out how good you're doing at understanding these symbols. What does it mean to have the U? We talked about the overlap, like the last one was the overlap. That's the middle. We know that. But the union's the trickier one. What does the U mean? The overlap, that's clear. That's the overlap, you know. But what's the U mean? What's the U mean? Well, if the overlap means both and, the union means either or. Either or. Unite. It'd be like if our class and an English class said, hey, let's unite and play softball. Have a softball game, right? That'd be all of us, right? Whether you're in this class or in that class, everybody's going to the softball game, right? That's what unite. Just unite the groups together. So that would mean, and we're uniting what? A and B. Everybody that's in A or in B, you're all going to the softball game. So the 2/21, the one in the middle, that. Just add those three together, huh? That's what the unite means. Just put them all together. The 2/21, the 163, the whatever, the 863. 15/63? Oh, but it reduces. 5/21s? Is that what it's coming out? You just use calculator, change to fraction, all that. 5/21. That's the answer to the last quiz of the union. Whew, that was a long problem, huh? Questions? All right. All right, here we go. A bicycle factory runs 2 assembly lines, A and B. And 95% of A's products pass inspection, 89% of line B's product pass inspection, 30% of the factory's bikes come off assembly line B, and the rest come off line A. Find the probability that one of the factory's bikes passed inspection and came off assembly line A. Ooh, that's a tricky question. Probability is not easy. Do you know what tool you want to do on this one? I don't think they should. If you just show me an example, they do something I think kind of strange. Tree. This one's calling out for a tree. Why? Well, because there's branching happening, right? In other words, think about this factory, right? And well, what are we talking about here? We're talking about whether they're cranking out bikes, right? And so any bike can come off assembly line A, or it can come off assembly line B. What are the percentages? You know, if you just grab a bike, if I just go grab a bike at random, hey, I found this bike. Did it come off assembly line A or B? That's the first question, right? Well, what percentage, do we know percentages on that? 30% of the bikes come off B. So this is 0.30. 30% of the bikes come off B. So what percentage of the bikes come off A? 70% of the bikes must come off assembly line A, because it's either A or B. There's no C. Good so far? Now, if it comes off A, it can either pass inspection or it can fail inspection. If it comes off B, it can either pass inspection or fail inspection. Do you see how do you see the idea? See why there's branching? Now that takes time. That's because I've done these for years and years and years. I just read it and I just smell trees all over it. But that's because I've done zillions of these problems. That's what you need to do. Because when you read this on the test, it won't say hit, use a tree. You'll just have to read it and feel the branching. that's happening. That's not Venn diagram. Notice I did not do. Why? What? Let me say a couple words about it because a lot of the battle is identification on it.
Say something
Test.
like
Yeah.
both. Like it didn't come
What's
out.
that?
Because you know how we always start off with the middle?
Yeah, that's true. They didn't say that. That's a good hint. That's a good hint. Also, with the Venn diagrams, we only have one characteristic that we're, well, that's not true, is it?
I've had three.
What's that?
I think it was like the senior ones, those had like three.
Yeah. So they could, huh? Yeah. I don't know. I just sense it. No, that's not very helpful, is it? No, it's the branching. You can try different things, but I feel the branching, right? The A, the B, then A passes or fails, B passes or fails. It's just nice. If I was to do a Venn diagram, like if I tried to do a Venn diagram, I think, okay, what are my circles? Is it like A and B? I could do that, but where's the passing failing going to go? You see the problem? Yeah, maybe that would help. If I tried that, then I go, how do I put the passing and failing? There's another characteristic. So you go, forget it. That's what it is. There's more than one characteristic going on here. There's whether you're from A or B and whether you pass or fail. Maybe that's helpful. Yeah, there's two characteristics going on, two levels of branching. Trees. All right. So with that in mind, let's try to summarize some results here. Get rid of that. Okay. So this is off A and passed. This is off A and failed. Right. I'm just taking the branch. A passed. Oh, wait a minute. What are the percentages here? 95% of A's pass. So 95%, which means this is 5%. 5% of A's fail. Right. 89% of B's pass. So 89% of B's pass. This must be 11. Good there. So now I'll do the branching. You can go A and pass. You can go A and fail. You can be a bike that's made out of B and then passes. You can be a bike from B and fails. What are the percentages here? As you go across the tree, you just multiply. That's the nice thing about a tree. Always. So I'm just going to take 0.7. Well, 0.70, if that's helpful. It doesn't matter. It's the same thing. 0.70 times 0.95. Whatever your calculator tells you that is. Well, I'm just going to write them out. I'll figure them out later. 0.70 times 0.05. This one's 0.30 times 0.89. This one's 0.30 times 0.05. Everybody see where I'm getting those from? I'm just following the tree. 0.7, 0.95. 0.7, 0.05. Right, I'm just following the tree from left to right. And you just multiply as you go from left to right. That'll be the various probabilities. Now, what's their question? Find the probability that one of the factory's bikes passed inspection and came off A. Passed and A. Well, that's right here. A pass. Passed and A. Multiply those together. Whatever that is, that's our answer. 0.665. That's the chance. What that means is 60. If you change that to a percentage, you don't have to. We're done. That's the answer. But what that means, I'm going to be real with you. Real life, what that means is 66.5. If you moved it back to percentage, 66.5% of all the bikes came out of A and passed. And you could find the different percentages for the different groupings. Right? They either came out of A and passed, or A and failed, B and passed, or B and failed. We know that 66.5% came out of A and passed. Is that good? All right. So again, you got to do this on your own. I'm kind of prompting with all the right questions, all the right tools. It won't be that way for you unless you practice on your own. We're doing on time. Okay, half an hour. So the table shows restaurant. So you see what's going on with this restaurant? So here's lunch. At lunch, 31 people thought the service was good. 38 thought the service was poor. 69 total. Dinner, 31 thought it was good. 17 thought it was poor. 48 total. And then there's the totals. So there's lunch and dinner and the totals that thought the service was good or poor. Okay, so what's their question? Find the probability the service was poor given, there's that word, conditional probability. They're given a condition, given that it was lunch. So notice if you grab somebody at random that had lunch there, what's the chance the service was poor? Can you figure that out? Give you a chance. Remember what the given does? It determines the denominator. It limits the field. It makes it lowers the total, the denominator, right? Okay, so the probability that it was poor, given it was lunch, that's what they're asking me. Given lunch. Okay, what's probably the service was poor? Well, first off, what's the denominator? What's the new total? How many people had lunch? 69. That's the total lunch goers. It had to be one of those 69 people, right? We're given that it was somebody who had lunch. The meal was lunch. 69 people had lunch. It's one of them. It's not the other 48 people who had dinner. It's not the whole 117. It's one of those 69 lunch goers. It's out of that group, right? They had lunch. And out of that group, how many had poor service? 38 out of 69. There we go. That's all they want. They want a fraction. I don't think that fraction reduces. No, that's just it. Good on that? How we doing? Is it all making sense? I'll move on. Okay, the table shows relative frequencies for red-green color blindness in one doctor's practice. M represents person is male, C represents colorblind. Use this table to find the probability of M. Okay. So what's the probability of M? It's just right there. Unless I'm missing something, that's a silly question. There's no given. There's no special condition. What's that?
Is there other part too?
Yeah, maybe, huh? Yeah, so everybody see that? So not M, not C. It's just right there. Because it's not M, not C. They overlap right here. That's overlap 0.519. Yeah, maybe I could help this way. Here's the not C people. Here's the not M people. Where do they overlap? 0.519, huh? All right, let's move here. Okay, so probability of M given not C. Remember, that line means given. That line means given. So that line limits the field, doesn't it? Right? You're given something. You're told something. That'd be like me saying, hey, what's the probability that the Giants are going to win the World Series this year? Doesn't look very good, huh? It's early. We'll see. Once his name gets back in there. Bumgardner. I'm actually a Dodgers fan, sorry.
Thank you.
Yeah.
Thank you.
I really don't care a lot, to tell you. It's all laundry, I think, in the end. But anyway, I agree with Jerry Seinfeld, who said, in the end, you're rooting for laundry. They all change teams anyway. There's a lot of truth to that. But anyway, what if I say, what's the chance the Giants are going to win the World Series? Given I looked into the future and they actually make it to the World Series. That would change the question, wouldn't it? If you were given that information, right? Or what if I said, what's the probability the Giants are going to win the World Series? But let me give you this fact. I just heard the report. Bumgardner's not coming back. His injury is all season. That changes the probability way down, doesn't it? So you see how, do you know in the end, probability is all about information? That thought ever occurred to you? You ever sat around and thought a little bit about probability? That's why insider trading is illegal. What am I talking about? What did Martha Stewart go to jail for? Go to prison for?
Didn't she tell like something was
For lying under oath, right?
I thought it was insider trading was the original issue.
Well, yeah, that was the issue when
Looks like
but
so.
then she-
I think
And then she lied. Did she?
Wow.
You guys know it way better than me. Yeah, so I just know it was originally insider trading.
Yeah.
What is insider trading? That means she knows what her company's going to do, and then she traded stocks around. Well, that's not fair. You got to have the same probabilities as everybody else, which means you can't have more knowledge. See, probability is about knowledge, isn't it? Randomness, there's nothing random, really. Whatever's going to happen is going to happen. We just can't see the future. So all the probability is lack of knowledge, really, isn't it, in the end? We just don't know the future, right? So if you know certain things, like if you were a Bumgardner's doctor and you'd looked at his arm or whatever and you're like, he ain't coming back. That's going to be all season. You don't want to let that, the Giants don't want to let that information out. Their attendance would drop because there's almost no chance they're going to make the World Series if Bumgardner doesn't get back in there, right? For example, right? So I'm just showing you that that's why the given matters. If you're given information, That changes the pool. If I said, hey, I rolled a die. What's your chance I got a 2? By the way, I got an even number. Well, then that makes it more likely, huh? It changes things. So given information, that's why insider trading is illegal. You can't know what that company's going to do, and then that's not fair to everybody else. So, all right, let's get back to it. So, we're given this, which means what? We're on one of those two. Well, I'll circle the whole C prime row. We're on the C prime row. We are not anywhere else. We're given that. C prime happened. Whatever it is. I don't care what it is. It's C prime. It happened. Not colorblind, I guess. The person's not colorblind. Right? Not C happened. So we grab somebody at random. They are not colorblind. Okay, what's the chance they're a male? Well, it's this. It's 0.515 out of what? Out of that total. 0.949. Do you see why I don't just say it's 0.515 done? Because that'd be 0.515 out of 1. It's not out of 1, it's out of 0.949. It's out of the total colorblind. Right? It's like me saying, I rolled a die. What's the chance I got a 2? By the way, it's even. Well, then that would change the bottom. It's out of 3 now. It's 1 out of 3 instead of 1 out of 6. If you know it's even, you'd limit it to only 3 things happen, 2, 4, or 6, instead of all 6 things, right? If you know the person's not colorblind, then it limits it to 9.949, 94.9% of the population. It's one of those people. It's not one of the colorblind people. What's the chance they're male? Whatever that reduces to be. Round it to 3 places on your calculator. I'm going to move on. Is that good? So the main thing to know, that this is the denom. That's the total denominator. The total C prime is right there, the denominator. The given is the denominator. Yeah, how about this? It's almost like a fraction. If you turned it a little bit, it would look like a fraction, huh? Does that help? The thing after the line, imagine it like a sideways fraction. That's the denominator. That limits what can happen. That's the given. That's why it was bad of Martha Stewart. She knew what that company was going to do, right? I'm not here just to bag on Martha Stewart, but I'm just giving an example. You know what's the new thing you have to get? The real ID. I don't know if you got that. They have this new driver's license thing you got to get eventually if you ever want to go out of the country. You have to have this. Anyway.
Oh, the bear on the right-hand corner?
Yeah, it's got a new symbol on it. You know, it's time for me to re-up. I'm 50. I had to re-up my driver. I haven't been to the DMV for a long time. And I made an appointment. You never go to the DMV without an appointment. Yeah. I made an appointment, and then I ended up wiping it off because I can't go that day. And I tried to get like 3 days later, and it was beyond my birthday, so I had to walk in to the DMV. That's just the worst thing in the world.
If you don't have that, you can't travel to other states. That's the thing.
That too? Yeah.
That's the thing where they require you to have a passport instead.
Yeah.
Yeah, and then the right-hand corner shows if you can buy a gun or something.
Oh, that too?
Yeah.
Buy a gun, travel states, go out of the country with your gun? No, I don't.
Yeah, it's just the weirdest
No,
thing.
I know, but yeah, they're limiting all kinds of things. You got
a
to.
passport within the United States, and then that was the reason
Seems funny, huh?
they
Yeah.
changed that on the driver license.
So I showed up at the DMV. I'm just hoping. I go, or Friday morning, I have Fridays off, so I go in there. Thought I get there about 10.
Which one did you go to?
Clovis, the one that's.
Oh, that's the best one, honestly, though.
The wait times were lower. Why? Because I checked. I went online, made an appointment at both, because I'm kind of in the middle. Made an appointment at both, and it was it was quicker, even though both were beyond when I could make appointments, so I didn't keep either one. They were beyond my birthday, and I had to go in by my birthday. And but yeah, Fresno put me off even like 2 more weeks,
Yeah.
so that must have been more packed.
Yeah.
I determined from that.
Close,
Yeah.
you show up early in the morning, like before anybody's there. You
Really, my buddy. I was on the phone with my buddy 2 days ago, and he's a physical therapist. I was asking about my shoulder, and I gave him a call. Hey, my shoulder. Should I go into the doc? What do you think, Adam? And I was like, what are you doing, Adam? He's like, I'm at the DMV. He was there, and I was like, I was there Friday, Adam. He's like, yeah, I got here at 8 or 8:15. There's a line out the door. I went at 10, same thing, line all the way down the sidewalk. I was there for 2 hours and 45 minutes at the DMV. It was crazy. Anyway, I'm telling too many stories. All right. The DMV, here we are, Department of Motor Vehicles, says, make an appointment is the moral of that story. The whole time I thought, Brett, you were stupid to not make an appointment. That was stupid. You're paying 2 hours and 45 minutes because you're stupid. All right. The DMV has found that the probability of a person passing the test for a driver's license on the first try is 0.7. Oh, but I passed it. I'm still telling the story, sir. I passed my vision test. I was super excited. My wife and kids, I need glasses for reading now. You know, my kids will show me their cell phone. Look at this, Dad. I'm just like, they're like, Dad, but I thought, I can still see far. My wife isn't sure about my driving. I'm like, I can see far. I'm good. So I was really excited. It was the moment the lady said, okay, read those letters. And I could kind of see those letters. And I read those letters. I'm like, am I right? She's like, you're right. So I was excited to tell my wife and kids, I told you, I passed the vision. I'm still good with, sort of good. Watch out for me on the road. I'm a little scary. So I'm passing still so far with long vision. All right. Department of Motor Vehicles, 0.7. Chance of passing the first try, 0.7. Probably that an individual who fails on the first test will pass on the second, 0.8. Find the probability the individual fails both the first and the second. So this isn't the vision test. This is the written test. So, or maybe the driving test, whatever. Do you smell a tool? What tool do we need on this one? If I did a VIN, it's not a VIN. If I did a VIN, I would have like, what would be my two circles? What are they talking about? Whether you pass the driver's test the first time or pass the second? I guess I probably could do a first time, second time. You know what? This is a tree. Why? Because can you feel how life happens? That's what branching is. Like it's like they talk about the paths of life. You choose to go to college or not go to college, and you choose to get this kind of job or move out of state or not. The different choices people make and how their life branches out. Well, that's kind of like what's happening here. The person comes in and takes the test, and they pass or fail the first time, right? And then, if they pass the first time, they're done. But if they fail the first time, then they take it again, and they pass or fail on the second try. Do you see that's kind of like what it's indicating, a branching of taking, right? Because if you take the test and you pass the first time, you're done. You don't retake it. If you fail the first time, then you take it a second time and you either pass or fail, right? That's branching like that, okay? And then let's put the probabilities on there. What does it say? Passing the test for drivers, first try, 0.7. So that goes right here, 0.7. This must be 0.3. Fail the first time. We good there? They got to add it to 100%, right? This is 0.70 if that helps you, 0.30, whatever, either way. Same thing. So far, so good. Maybe I should squeeze this in back over here. 0.30. So 0.30, 0.70. That's what they're telling me. First try. Now they're saying the probability of the individual who fails on the first test, that's this person, right? Failed on the first test, will pass on the second, 0.8. So 0.8, so then this must be 0.2. Because the two branches have to make 100%, right? The second time you take it, you either pass or fail. They got to make a 1.0 100%, don't they? Right? Just like these two have to make 100%. The branches always have to make 100%, coming off any root. All the branches off any node, any root, have to make 100%. Okay? So here's fail, pass, fail, fail. What's the percentages? You just multiply, right? 0.30 times 0.8, 0.30 times 0.2. What do they want from me? Probability fails both first and second. Fail, fail. Multiply these together. What is that? 0.06. You should use your calculator. Yeah, 0.06, 6%. That means 6% of people fail twice in a row. So it's kind of interesting. We can figure that kind of stuff out. Is that good on that? That makes sense? Getting the feel of trees. It's when there's branchings, when things happen, one thing after the other. Yeah, that's a lot of it. Trees are a lot when one thing happens after the other. Maybe that's another way I can describe it to you. So it's funny. It's hard for me. I've done it for 30 years. I've done trees. So I just natural for me. Trying to think, why do I know that's a tree? It's because one thing happens after the other. Right? You take the test the first time, you take the test the second time. Right? Like back over here, what did we do? What was our last tree one? Another tree back here ways. This was, comes out of factory A or out of factory B, then it passes or fails after it comes out of factory. Yeah. So it's one thing after the other is another way of telling it's a tree or not. DMV here today. So, Department of Motor Vehicles has found that the probability of a person passing the test for driving, 0.7. So we're doing the thing again. Let's do they pass or they fail. This is the first try. And it's 0.77 for pass. So subtract from 1, you get 0.23 for that one. Take 1 minus, Add up to 100%, right? That makes sense so far. Next, find the probability that a person will require at least 2 tries. Find the probability. See their question? The probability that a person will require at least 2 tries. I already answered it. Why is it 0.23? That's the fail mark. Yeah, because that's exactly what they're asking. Right? If I said, if a person requires at least 2 times, that means they failed the first time. That's a funny way for them to say, what's the chance they failed the first time? Do you see those words are equivalent? There's the lawyer reading the words and seeing exactly what they mean. Right? That's what it means to take it at least 2 times. That's a fancy way of saying you failed the first time. That's just 0.23. That's all they're asking. Make sense? Okay. Finally, probably the customer cashed a check given the customer did not make a deposit. Let you try that. Remember the given. See the little given there? Given, that's the line. That's like the fraction, right? And this is the denominator. Remember, that's how I'm trying to, it's my new technique, try to help you remember how the given, it's like the right side is like the denominator. It's like a sideways fraction, right? It's like the denominator. That's the total on the bottom of the probability. This is the denominator. Customer did not make a deposit. So did not make a deposit. What's that? What number? If I said, hey, we got a customer, that customer did not make a deposit. How many people have we limited the field to? 32. Everybody good? It's the total for not deposit. The not deposit total, 32. Everybody seeing that? There's 66 people altogether, but 32 not depositors. And we know we're given, we know for sure it was somebody who did not make a deposit. So that's the denominator. You getting the hang of that with the given? That's always the denominator. It's like a sideways fraction. This is the denominator. So what's the numerator? Cashed a check. What's that? Remember, we're talking about only this group. Don't look anywhere else. It's got to be in that field. Remember, that limits the field. So don't grab that 39, for example. It's just the 21, huh? Everybody seeing that? The given limits the field. Like if I said, I rolled a die, what's the chance I got a 2? Given it's even, then it limits it. It had to be 2, 4, or 6. If I tell you it was even, right? When you're given information, it limits the possibilities. It limits the denominator. It limits everything, right? If we're given, they're given that they did not make a deposit, then it's this 21, 11, 32 group. It had to be them. Forget about everything else. Right? So out of that group, out of those 32 people, 21 of them cashed a check, 11 of them did not cash a check. All 32 total did not make a deposit. Some of them cashed a check, some of them did not, but none of them made a deposit. Right? So it's 21 out of 32. Doesn't reduce, does it? I'm going to leave it. Nothing divides on that. Nothing reduces. I want to get to those, but... What did I just do? I did something wrong. Hello. There. All right, there it is. So, all right, so give it a try. They're saying, given, here's the given. So this right here is the denom. Right? Customer cashed a check. So go up to the table, circle only that group. Limit the field. You're given it's an even number, so it had to be 2, 4, or 6. You're given that the customer cashed a check. You're given that. You know that. So it's these people. Forget about everything else up there, right? Good with that? It's those people. Some of those people and those people only. Cashed a check. So out of those people, that's the denominator. That's the 74 denominator, right? So out of those 74 people, so out of those 74, answer the top part. Did not make some other transaction. What does this mean? Let's make sure it makes sense. 29 people cashed a check and made a deposit. 28 people cashed a check and made a withdrawal. 17 people cashed a check and made some other transaction. 74 people total cashed a check. So they're saying, the customer did not make some other transaction. They're not one of these 17. They're not these 17.
57.
So it's,
29 plus 28.
yeah, it's 29 plus 28, whatever that is. It's the other two groups, huh? It's not the other. It's the 29 plus the 28. Good? Whatever that is, 40, 57 out of 74. Is that okay? Are we happy? Are you thinking about going home and making your DMV appointment? Anybody need to go in real soon? You made an appointment. You're so much wiser than I was. You won't be there for 3 hours. I was joking with the lady at the front. Well, she was joking with me. I was like, 2 hours, 45 minutes, I guess that's to be expected. I just listened to an audiobook the whole time, so it wasn't that bad. But then she said to me, yeah, it was Friday, the last Friday. She said, Monday, the whole computer system's changing. And we're not really ready for it. It's going to be terrible in here.
I've been there since then. It's horrible.
Yeah, was it? You went to the DMV this week?
They go by your phone number now,
Okay.
and where do they go? And like your initials. It's horrible.
Ah.
We're there for like hours.
This week. You went this week?
Yeah.
Oh, yeah, that's it. In common, don't we? We can talk about it, and we've all been there. All right. The probability that the first record of a singing group will be a hit is 0.32. If their first record's a hit, so are all their subsequent records. If their first record is not a hit, the probability that their second and all subsequent will be a hit is 0.16. If the first two are not hits, the probability that the third is a hit is getting pretty low, 0.08. Find the probability that at least one hit in their first three records. Tree. You starting to smell it? Because one thing happens, then later in life another thing. You go to the DMV, then you can drive your car, right? So this is you may produce your first album, it's a hit or not. Second album, hit or not. Third album, hit or not. Right? Seeing that? Tree. Yeah, try that. See if you can draw a tree now. Got the answer up there, so you can check the answer. Obviously, I've multiplied some stuff together to get that answer. So try it out. Try drawing yourself a tree now. I've been drawing them all for you. We've only got 2 minutes. Draw a fast tree. You can draw it. So it's going to be first record, hit or not. Second record, hit or not. Third album, hit or not. So the first one is a hit or not. That's the first record. And then, we don't even know. They said if the first one's a hit, all the rest are. So who cares? If the first one's a hit, you're a star, great. If the first one's not a hit, the second one might be a hit. So the second one might be a hit or not. And if the second one's a hit, it said, I don't know if you read all those words, if the second and all subsequent. So that's good. So we're only really continuing, kind of like taking the driver's test. You only have to keep taking it if you fail. So if you don't get a hit, you try again. All right, so that's your third record. Okay, so what are we doing here? Let's do the probabilities. It says the probability that the first record is a hit is 0.32. So that's 0.32. Not a hit, subtract from 1, you get 0.68. Remember, they have to add up to 1. Second one is 0.16, be a hit. The rest would be 0.84. The third one, 0.08, that'd be 0.92. All right. They always have to add up to 1, right? Always subtract from 1. What's the total here? Probably at least, this is where you got to read like a lawyer. What is it saying? What is it not saying? What is it precisely saying? At least one hit in first three records. At least one hit in first three records. Let's drive all these to the end. This was a hit on the first. All these branches have an end. This is not a hit and then a hit. What is this? This is not a hit, then a hit. This is not a hit, not a hit, not a hit. Right? How do you find the probability? At the end of a tree, the end of the branches, where the leaves are, how do we find the probabilities out there? We multiply as we go across. If there's more than one number, you multiply them. This one's just one number, 0.32. It's all you got. Next one, 0.68 times 0.16. Next one, 0.68 times 0.84 times 0.08. Bottom one, 0.68, 0.84, 0.92. Okay, now what do they want? At least one hit in their first three. At least one hit. At least, that would be, is that at least one hit? Yeah. Is this at least one hit? Yeah. Is this at least one hit? Yeah. It's everything but that last one, which is no hit, no hit, no hit. So just multiply those all together, add them up. Well, I mean, you know, these two would make whatever they make. 0.68 times, wait, 0.68 times 0.16. No, I can't do it that fast. I'm getting 0.1088 for this one. Come on. 0.1088. And then this bottom one here is, it's really small, 0.0088704. And then you have to add this and this and this. Add those, and you'll get that answer. You know what else you could have done? You could have just figured this out and subtracted from 1, because that's the opposite. That's another way. All right, we did pretty good. We got all but one question, I think, right? 19 out of 20. That's better than I thought.